This segment is brought to you by Starrett Kinemetric. Starrett Kinemetric designs and manufactures innovative precision, video-based, and optical comparator measurement systems.
And joining us right now is Greg Maisch of Starrett. Hi, Greg. Thanks for joining us. I think most of our readers, and I want to set up this next segment a little bit. We're going to be talking about a what do you call it? A video? What's kind of the generic name for the product?
It's like a machine vision system.
A machine vision system. So most of our readers, particularly if they've been in the industry for a long time, are familiar with optical comparators or shadow graphs, as they used to be called back in the 40s.
Right.
But those have already changed quite a bit. I mean, it's kind of not your grandfather's optical comparator or shadow graph anymore. They're usually vision-based, and kind of tell us kind of what we can expect to see in today's modern optical comparator vision measurement system.
Yeah, exactly. It uses a lot of the same concepts in that you're still measuring the shadow of the part with the collimated backlight, but instead of using a Mylar overlay with a tolerance band, you're going to be using a software that can tell you where your edges are and measure all those things much more quickly and in a lot more various ways. And then all that data goes to wherever you need it to be.
Okay. Well, we did record yesterday with you a video clip of the Flip HVR100, and we're going to run that in just a second. But just a reminder, if you've got questions about this type of equipment, send them to qdl@qualitydigest.com or tweet @qualitydigest or chat to us, and do that now so we get those questions in when we come back in about, I think, 8-9 minutes.
That's right.
So why don't we run that clip now? So, Greg, we're going to look at this is the Flip HVR100, right?
Correct.
Okay, tell us about it.
All right, yeah, so this is our new large field of view system. It's a benchtop model, and the main features that it has is that it has a very large field of view, about 90 millimeters on the horizontal, and that it can either be in the vertical or the horizontal orientation.
Okay. Meaning you can, right now we're seeing in the vertical, you're saying this can be laid down.
Correct,
okay,
yeah,
all right, got it.
Exactly.
Okay. So show us what it does.
Alrighty, so let me put this part up here. And then if we look at the software, you can see this basically it's a piston head.
Okay.
And so the way that this unit works is that it can pick up the contrast between the light and the dark regions. So that's how it does its measurement algorithm. So if I go ahead and click that line there, you can see it sees that as a line. It sees that as a line, and then it'll auto-recognize circles as well. Okay. You can just click these. Click around, and it's basically as simple as that. If you want to do, some fast and dirty type of measurements, you can just put a part up and start clicking on features.
And pick up a radius as well, I'm assuming.
Yeah, exactly. So you could grab this little arc right here.
Okay.
And then you can make measurements between various features. So you could take, basically these two circles here.
See them on the right.
And you can see them on the bottom here, like that. And another thing you can do is it typically goes to the center of features, but you can change that as well. So you can have it do the nearest points, the furthest points, and it's simple to switch it between millimeters and inches as well.
And what kind of accuracy are we talking about?
This is about 8 microns worth of accuracy, and repeatability.
All right.
Yeah. So that's a good example of how simple it is to just pick up any old part and measure it. Another thing that's very useful is basically the part recognition software. So what I'll show you now is if we go ahead and start a new program here, you can turn on the auto part functionality, and if you put a part on the stage, it should basically pick up that it's seeing something and measure it, just like so.
Oh, wow. Okay, so you're saying that as long as, so it recognizes the part shape. So as long as that part is in the library, that when you put a part down, it just detects the shape or the features or something and correlates it to that part stored in the library and just automatically brings up the parts program.
Exactly. So based on the shape of the part alone, it can tell what it's looking at and run the program and basically measure whatever features you'd like.
So this takes the place of typically in the past, what you would have done is maybe brought up a menu of stored programs, gone through that, found the found the part you were looking for, selected that, and this simply takes the place of that. It's just automatic. You just drop it on there.
Exactly.
It's great for the shop floor guy.
Oh yeah, so the shop floor guy, they don't actually need to.
Yeah.
They don't need to know how to find all those parts or where the libraries are. They don't even need to have access to that stuff.
Okay.
You can literally just put a part on there and measure it. Okay. So if I'll show you another part here. This one.
I noticed you turned off the light. So sometime when might you use the top light here as opposed to just the bottom one?
Well, if you have a feature that's on the surface of the part, but it doesn't go all the way through,
okay.
that's when you'd want to be using your top light. In general, we suggest you use the profile light. They tend to be a little bit more repeatable.
Okay.
Yeah. So here's an example of a slightly more complex part we put on here, and that should also trigger the auto part recognition. And there you have it.
So it doesn't even really care about orientation. You just kind of plop it on there and it's going to self-orient.
Exactly. No matter which alignment you put on the stage, it'll be able to skew it and measure your part regardless.
That's pretty cool.
So yeah, you can put hundreds of parts in the library and have them all measure this way.
Yeah.
It's very, very efficient.
All right.
Let's see. Another thing I'd like to show you is the basically its ability with round parts, because these ones pretty much that I've showed you have straight walls and straight edges.
All right.
So here is an example of a round part, and this is actually using a brand new module that our software guys at metrology just released. So this is a thread module. And what this allows the program to do is to basically tell you, a bunch of information about the thread very quickly.
Okay.
So you use your thread tool here. It's as simple as clicking and dragging over the thread. And then there you have it. Put it in millimeters since this is a metric thread.
That's
and there's your measurements for you. So this is
thread wires and a micrometer. So
exactly. So this is it's a lot faster than that. So this is an M6 by 1. So you can see there's your outside diameter. There's almost 6 millimeters. There's your root diameter and your pitch diameter.
Wow.
And then here is your there's the pitch itself, which is 1 millimeter.
Okay. Now I noticed that you're changing the height of this. I'm assuming that that's to focus on parts depending how high, whether they're sitting right on top or in this case, 2 inches off the base. Okay.
So the system has a very large depth of field. It's about an inch that it can measure within.
Okay.
Now, even outside of that depth of field, to the eye it'll look and focus. However, if you zoom in the software, you can actually see, the pixels here, and then you can see your optimal measurements. You can see it moving in and out of focus a little better.
So if you wanted to really fine tune it, you could just zoom in and just...
Exactly. Yeah, okay. So depending on how much accuracy you require, the best way to get your best focus is to do that.
Okay.
Yeah, so that's a pretty good example of a round part. And then another functionality we have is the digital comparator function. So what this does is it allows you to use an overlay similar to a comparator, which is still very very useful for certain shops. They prefer to have that overlay with the tolerance band on it.
Right.
And it's very simple to do so with this software. So what I'll do is, and you can see, you might be able to see it's a little bit out of focus now, but we'll go ahead and move it into focus. And next thing I'll do, so basically in order to get your overlay to snap onto the part correctly, you need to tell it the origin of the part. So that's what I'll do here by setting up a datum and a skew. So we'll skew this top line here. We'll grab this left line here, and then where those two intersect is the datum of the part.
Okay.
And then basically what you do is you have a DXF of the nominal, generated through CAD or what have you.
Sure.
Go ahead and open that up, and it should just snap like so. So you can see there's an actual overlay here with the tolerance band on the part.
Okay. Now this could be set up to do kind of no-go, right? Where it would compare to the tolerance bands, and if it's within or without, it would give you an indication of the part passed or failed.
Exactly. So it'll not even just the part passing or failing, but certain features within the part.
Okay.
And those features can also have different tolerances based on your needs for manufacturing.
Okay, so you don't have just one tolerance band that for all features, each feature can be set up with its own tolerance.
Exactly.
Okay,
so you can tolerance the features as necessary.
Okay.
Yeah. So that's a good example of this functionality.
Okay. And then finally, why don't you tell us a little bit about how you make this thing horizontal?
Okay, yeah, so it's rather simple. Basically, you got a little piece of bodywork here that needs to be removed. And then the stage here actually just flips 90 degrees like so. And then there's some rollers on the back that it just uses to pivot on. And there's a handle here on the top. And you just, go ahead and lay it over backwards. And then, so for some people, or some shops, they prefer to have that horizontal orientation, particularly for fixturing turn parts. A lot of times we see that a lot with our other horizontal systems. So we figured, hey, if we could offer a machine that offers both functionality in vertical and horizontal, and have it be price competitive with a machine that does just one of those things, that would be in a very good place.
Right, perfect. Well, again, this was the Flip HVR100, right?
Exactly.
Okay,
yes.
Perfect. Thanks for showing it to us.
Hey, thank you very much for having me.
Thanks, Greg. That was a great demo. But before we get to the questions on that, we have some coming in.
We do have some coming in, yeah.
We did have, I knew this was going to happen. Somebody did have a comment about my B89 riff there for a while. I don't know what this says, but let's see what it says. Okay. Oh, well, that's simple. Okay. And from our buddy Alan Metzel. I knew Alan would say something. B89 committee formed in 1963. So that was a ways back.
So yeah, you were saying that that fixed CMMs were actually before that. So fixed CMMs
been around
came
for
on
a
the
long
scene,
time, and
then
40s,
the committee formed because they said, hey, we need a standard about this, to deal with that. Cool.
Yeah. Okay. Good.
Excellent.
I was afraid somebody was going to say you are a complete idiot.
Well, that you can read between the lines on that one, Dirk. But I mean,
but Alan's being nice.
Thank you, Alan. And we know Alan. I'm sure that's Alan Metzel. Thank you, Alan, for giving us that information. Alan. Good job.
All right. So some real questions. What do we got for Greg here? Oh, okay. How asymmetric does a part need to be to assure proper automatic recognition and registration?
Mm-hmm.
Well, I don't know exactly how I'd give you a quantitative answer on how asymmetric it has to be. But for the most part, even symmetric parts, I haven't had too much of an issue with the auto part recognition. I haven't run into an issue where it wouldn't pick it up, even doing something like a washer. Yeah, so as far as I know, the symmetry, it probably is somewhat important, but we haven't run into any problems in the field.
And I think also I believe you told me in order to speed up the process, they went from something like complete mapping of the part and trying to do it to some sort of mathematical, it sounded like some sort of mathematical analysis of the shape, and that's what they're doing right now, or something like that. Is that what you were?
Yeah, as it was explained to me by our software guys over at Metrology, and they'll probably correct me if I'm wrong here, because I don't necessarily understand exactly what they've done, but I know that instead of looking at all the points in the point cloud, they're looking for specific shapes on the part, and that really speeds up basically the search time that it takes. So when you see that little searching for patterns dialog there, that they cut that way down because of that new software development that just came out about a month ago. So that's really nice.
I gotta believe that for the shop floor guys, this is actually pretty darn cool, because I mean, I think we mentioned it in theirs. I mean, and I've seen people do that. Even if it's an automated machine, they've got to bring up a menu of all the parts. They search through the part. They click on the part. Maybe they click the part just above. Maybe they misclick, right? And it's like, oh, it's the wrong program. This, you just plop it on there, and 4 seconds later, you've got your part program.
Oh yeah, I would imagine the throughput is much higher just because of that.
fewer errors. Yeah.
Oh yeah, way fewer errors. You don't actually need to know what the programs are. You don't even need to, navigate to any kind of folders. Yeah. As long as it's programmed in there, it'll stick and it'll just find it for you. It's really easy that way.
Ah, cool.
And this is a brand new product, right? I mean, this is just out in the last couple of months.
Yeah, I mean, these are really, that was a pre-production unit. Wow. Where I believe at the quality show here in a couple of weeks, that's where we're going to really launch it. So you guys are really seeing the first demo of that product. That was literally the first demo we've done. I built that machine myself last week, so it was.
Cool.
I'm glad we're seeing it here before quality.
Yeah.
There you go. See it here first. That's right.
Yeah.
Good job. Thanks.
All right.
All right. Well, let's take a look at the next question here and see what else we have for you. Okay. Starrett produces a wide variety of video measurement systems. So what sets this one apart from the competition? Good question.
Yeah, great question. And I think really what it is first of all, the very, very large field of view in a very small package. This actually has the largest field of view of any of our systems, including the large, huge floor standing unit. but it also has the ability to flip in a horizontal or vertical position, which those are really sort of what differentiates our product lines traditionally, is what, which way do you want to fixture your parts? Do you want to do it horizontal? Do you want to do it vertical? Once they figure that out, we kind of go from there.
Now, why would you want, what's the advantage of being able to flip it horizontally rather than, I would think it's going to do the same thing either way, right?
It will, exactly. It will actually do the same thing either way. It sort of depends on the kind of parts that you're going to use. If you have parts that need a lot of fixturing, a lot of times the horizontal position is a lot easier because you just have, there's sort of more room to work there. It doesn't have to sit on the glass. Whereas if you're using small parts that are going to fit entirely in the field of view, a lot of times the vertical orientation is easier, just because you can just plop it on the glass and off it goes.
Gently set it on the glass.
Yeah, don't drop it. Right?
Okay.
I think I have some more questions coming in.
Okay. I'm not sure we talked about that. Data export options for the software. So almost all suppliers and customers usually want to have some sort of inspection report.
Yeah, exactly. So the what's really nice about this software is that you can actually put that as part of the program. So that automatic inspection procedure that I just showed run, you can have it generate a report, either a CSV or an Excel file or a text file. It'll export those to wherever you want them to go automatically. You don't even have to run a report. You just put the part on, and as part of that automatic program, it just sends the report without the user even having to think about it. So there's a lot of different ways. It can also do DXFs. If you want to see an actual drawing of what it measured, you can do that as well.
Are the reports customizable? Put your logo on them, all that kind of stuff?
Oh yeah, you can customize the reports. You can get them. There's a lot of things you can do with those.
Okay.
I'm not an expert in how to do that, but I've seen some pretty cool stuff done that way.
And modify it specifically for your
organization,
clients.
for the kind of the company that's working with that. Absolutely.
Absolutely.
Cool. All right, let's look at the next question here. Okay, what size workpiece can this product accommodate? What's the capacity in terms of different larger or small pieces that it can accommodate?
I believe weight-wise, you're probably going to look at right around 20 pounds for the system. As far as size goes, the whole part doesn't have to fit in the field of view, but whatever features you want to measure do. So you might have a larger part that has a feature that you want to measure on there. Of course, if you have features that are too far apart, you're not going to have the distance between them because it only has the field of view measurements. However, because it has such a large field of view in the first place, a lot of parts are just going to be able to, you're going to see the whole thing, and you don't have to go around and look for each feature the way you would with a more traditional system with a zoom lens, moving around, doing all the features individually. It's just going to take one shot of the whole thing and give you your whole report all at once. So,
and I think you touched on this, backing up a little bit, I think you touched on this a little bit in the video, is depth of field and focus. And so tell us a little bit more about that, because I saw you adjusting the head in order to do focus, but I wasn't seeing hardly any change until you really zoomed in. I wasn't really seeing that much of a change from my naked eye.
Right.
On it. So how important is it to get this thing exactly focused, given that I think you said this thing has a huge depth of field?
Yeah, it's got a very large depth of field of about 25 millimeters.
Okay.
So that was actually a problem for us in engineering when we were looking at this lens, moving it up and down. We weren't seeing the difference. We were like, okay, where are we actually working at? So we originally were using basically a ruler to make sure that we're at the right working distance. But then what we noticed is if you just scroll in with the scroll wheel or pinch zoom on the actual image on the screen, you'll start to see those pixels themselves.
Okay.
And once you can see those, it's actually a lot easier to zoom it. But it is very important to get it within that 25 millimeters depth of field for accuracy purposes. It'll drop off pretty dramatically outside of that.
Once you get outside of it, because the edge is defined, so it doesn't really know where the edge is on the part.
Exactly. The algorithm will not be able to interpret it as accurately as possible.
Okay. Now I noticed you also have the capability to top light. Where would you use that as opposed to just strictly doing a shadow?
Well, anytime that you're going to have basically something cut into a profile, but it doesn't go all the way through the part.
Okay.
Like let's say you just have something milled onto the surface, but it's not a through hole.
Okay.
That's typically where you'd see that used.
Oh, but the same tools would work, except now rather than clicking on the edge of a shadow, you're actually clicking on the edge of a feature that's being lit.
Exactly.
I have that basically.
So yeah, and that becomes a little bit challenging just because the algorithm runs using contrast, so it's looking for a change in light value.
Okay.
So you do have to do a little bit of work to make sure you're getting the contrast that you need, but there's some tools in the software that'll make that easier as well. There's an edge teach, so you can tell it specifically what kind of contrast by basically clicking and holding on a point, and it'll say, okay, that's the contrast level we're looking for, and that'll make it much more accurate. And that's typically when I do applications for customers. You see that quite a bit.
Okay.
So what piece of equipment is this generally replacing? What Starrett equipment is this replacing, and why was the features of this product so valuable for the customers that you were hearing from? What are they looking for that this really addresses?
I believe it's, the obvious thing that would be replacing is probably an optical comparator, or possibly even another type of vision system, depending on what they have. The very large field of view, that's really the benefit of this specific system, and its compact size. The fact that you could put these, it's a benchtop model, you don't have to dedicate a whole bunch of floor space for it. And its ability to be in either position really give it a lot of versatility. So it could, it could replace a vertical type machine, it could replace a comparator, it could replace, or work alongside those as well. It's just, it's sort of, it'll be interesting to see what industries demand this the most here shortly. So
All right.
Cool.
So we have another question.
We have another one.
How many parts at one time can it handle?
Oh, that's a good one. Yeah.
Yeah, so actually with that part recognition playback, it can do multiple parts in the field of view. So if you have more than one part with patterns, it can actually go through and look at all of those and give you reports on each of them. How many it can handle, I want to say, and I'm not entirely sure because I haven't talked to our software guys about this specifically, but I want to say it's probably realistically around 10, just because of the size of the field of view. And if you have parts that are too much smaller, there is a limitation on the size of the part. Like, you don't want to be measuring something that's a millimeter across with that machine, just because you don't have enough pixels to get really good data.
Yeah.
So I'd say realistically somewhere between 10 to 15 parts would be what you could expect.
And just, I'm not sure I understood the question. Are they talking about if you put multiple different parts on the stage? Is that what they're talking about? Is how many parts at one time can you measure?
So it'll actually, if you enable multiple part in the field of view playback, you can have multiple copies of the same part in the field of view, and it may in fact do different parts. I'm not sure about that. I know that the software guys were looking at doing that. I've never seen that happen, but I know for sure that you can put multiples of the same part as long as they all fit in the field of view, and then fire the measurement trigger and tell it, okay, here it is, and it'll tell you, here's all the reports for all of them.
Pretty wow.
So yeah, that's nice.
Pretty cool. That's pretty cool. Let's see, another question here. Will the video be available for vendors to show to customers after this event is complete? That one's for us. Okay. So the answer is yes. This is going to be the entire episode, the entire show that this whole thing.
2+ hours. We're almost at 2 hours already.
Will be on YouTube, but individual segments, I imagine, as well.
We will as well. Yeah. And you'll be able to check it out. We'll have an article coming out recapping the show early next week, so you'll be able to check that out, and you'll be able to click on the individual pieces of the show and check that out also.
Okay.
So yeah, look out for that. And it's like I say, I think it's been a great show. We've enjoyed having it. So I think that hopefully any of you who missed it will be able to catch it on the rebound starting next week.
All right. What software is included?
And ease of use.
Yeah.
So yeah, I think that video pretty well demonstrates how simple it is to use, and it's very,
and
very
intuitive. And the name of that software again was?
The software is actually M3 by metrology. So M3 version 2 is the current version of it. And yeah, we really like that software. Our customers really enjoy using that software. That's probably on the vast majority of our machines that go out.
Well, it looked like it was all just, click on a feature and it recognizes the feature and this is an arc, this is a circle, this is a line. I mean, it's pretty point and shoot.
Oh yeah, absolutely. Although that's not to, say that there's actually a lot of features in there that power users can use that get way more in depth than we really want to go into here. But there's it's got both, the ease of use for somebody just getting into it, and also a lot of, we have some really wild customers who are doing things measuring knees, like knee replacements.
Oh, like, yeah, right.
So
Medical
they have
device,
it,
yep.
they have it set up with rotaries and all different axes, and they're looking at profiles and all different, angles and things.
Give somebody a new toy and they'll figure out
A fair way to do it.
Oh, yeah.
feel out a way to tweak it. Yeah.
Well, that's what I'm saying. You had mentioned that this is so new that you're going to be going out in the field and you're going to be finding applications, and people are going to be, the customers that are going to be using this in all sorts of interesting ways. What do you foresee? What do you foresee some of those applications that you think are going to be the most common that people will use?
I think a lot of it will be, anytime you have a part that's going to require 100% inspection of like a smaller part that would fit in that field of view, any shop who's making a lot of those kind of parts, I think it would be extremely valuable, because you can have them pre-programmed, you can throw them on the stage, have it measure them, gives you a report, pass, fail, throw it in the respective bin, and you're off and running for every single part, and literally in seconds.
Yeah.
So,
Well, yeah, almost walk away. I mean, I could see if you were measuring the same part and you already had your focus set up.
Yep.
You set a part on there. You step aside. You grab another part. By the time you're ready, that one's done. Pull it out. I mean, you could sit there, just have somebody just keep feeding the parts, and it's going to measure it because it's going to recognize the part. And I think that's the other thing about that auto recognition is that you could just keep. Just as quick as you can put them on and make its report, you can feed it.
Oh, absolutely.
Yeah.
And that's, I think that's one of its biggest strengths is its ability to do that.
Okay.
I would like to see a lot more people use that functionality that way.
Yep. All
So
right,
medical device would be one, and a few other applications like that, a few other sectors.
Oh
like
yeah,
that.
absolutely. Medical device, we do some work with aerospace, defense contractors. Those guys, we see a lot of business from those industries. So, but yeah,
cool.
Medical industry for sure.
Looks like we have another question up there.
Question. Let me take this one. When the part is measured, as you are able to generate reports such as typical CM. When the part is measured, are you able to generate reports such as typical CMMs? What kind of tolerance or resolution can you achieve? Amazing product, by the way, and a little kudos for you guys on that one.
Hey, thanks, guys. Thanks. Yeah. So as far as let's see, we absolutely can generate a report. Like I was saying, it'll do a CSV text file, DXF. You can customize those reports as well. So that's very simple. And as far as the accuracy for the tolerances, the accuracy that we're seeing is about 8 or 9 microns with that machine right now for both flat, round, and square-sided parts. I think that's actually right about at the theoretical limit of the size of lens that we're using and the pixel density of the sensor, along with the capabilities of the algorithm to basically sub-pixel interpret those edges. Because 1 pixel is about 37 microns, but the software can actually sub-pixel and interpolate that down.
Right, yeah.
So we're right at the theoretical limits as far as our hardware and software are concerned there.
Cool.
One more question. What is the field of view, and what are the capabilities of this unit?
So yeah, like I was saying, the field of view it's very large. It's about 90 millimeters horizontally. So 3.65 inches, I believe that is.
Okay.
And like I said, the capabilities are sort of what we've been showing as far as the auto part recognition, the top light, bottom light, multiple different ways to fixture. I think that pretty much covers it.
And have you ever this is one thing I'm always interested in. So we talked about just the old standard optical comparators, that have been around forever. Have you ever brought one of these newer comparators or vision systems into a shop that's been using an optical comparator, and are the old timers kind of like, what is this newfangled equipment, and not really, do they get into like the whole digital aspect of it, as opposed to, like you said, having to lay a Mylar over a screen and do it that way?
So yeah, we've had varying responses from those kind of guys. Some of them are really into it. They really take it and run with it and understand the value. Some of them are kind of set in their ways, and they don't. We've had people say, this machine doesn't work correctly, and it's just basically because they don't want to get out doing what they've been doing.
Yeah.
But we've had good luck. Usually with a little bit of training, a little bit of showing them the benefits of it, they almost always come around, and they enjoy all the benefits that we have. Really, quite a few of our systems are built into literal optical comparator chassis.
Okay.
Because we also still sell those. We
Right.
sell optical comparators at our location.
Right,
So,
right, yeah.
you know, that still is part of our business for us. We still...
Well, that's right. So we don't want to badmouth optical
Yeah.
comparators.
No, yeah.
Starrett makes
Optical
great optical comparators.
that we do. Yeah, so there still is a place for those for sure.
And also, you know, obviously this is for a smaller volume. I mean, some optical comparators, I mean, Starrett makes them, which
Oh,
are
yeah.
gargantuan.
Yeah, exactly.
Yeah.
Our largest optical comparators outsize our largest vision system by, you know, multiple times.
Right, right.
They're very big.
Yeah.
Cool. All right, well, I think that's it for our questions. We're going to move on. That's it for the segment. Of course, we'd like to, again, acknowledge our sponsor before we do move on, and that's Starrett Kinemetric. Starrett Kinemetric brings you the HVR100, the latest example of Starrett product design and engineering. The HVR100 presents users with new solutions for increased productivity and decreased costs. Starrett equipment features modern, sleek designs and powerful yet user-friendly software. From application analysis, system specification, installation and training, to post-installation field services, the excellence of the Starrett line is matched by the quality and comprehensive range of their services. So for more information, visit online at www.starrett.com or call 978-249-3551.